Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap with a demo, but before we get started, I do have a few housekeeping items I need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, we do have a polling question during today's webinar, so hopefully we can get everybody engaged with that. And at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is improve the reliability of your Kubernetes clusters. Our speaker today is Ana Medina, who is the Senior Chaos Engineer at Gremlin. Ana, thank you so much for joining me today. Really appreciate it.
Thank you all for having me. I'm super excited to be here, and I'm excited to give this talk today.
Awesome, awesome. Well, I'm excited about this talk too. So I'm going to take myself off camera, put myself on mute, and let you get right to it.
Perfect, thanks. Well, good morning, good afternoon, good evening, good day to all of you. Thank you very much for coming to today's talk. I'll be talking about making our Kubernetes clusters a little bit more reliable. We'll have a little bit of conversations on getting started on chaos engineering. I'll do demos on some chaos engineering experiments that you can run, and I'll leave you with some resources that you can take back to your teams or actually start executing. So first, we'll start off with talking about outages. I know most of you in this call today can feel the pain of looking at your pager at 3, 4 in the morning and being, uh-oh, I need to hop on to figure out what's going on, understand what my system is going through that would get me to this page and fixing it so to make sure that our customers are also having a great experience. And when we talk about Kubernetes, we know that this is still an industry that is just getting started in terms of containerization and orchestration layer. And we're starting to see that there's been a lot of amazing wins that Kubernetes has brought on to our organizations and DevOps and site reliability engineering practices. But we also know that it has a lot of complexity, and that's what I'll be discussing on today. And I wanted to kind of touch base on outages at first to set the tone for today. And with that, I wanted to leave you all with a really handy resource that this amazing folk in the industry, Jacob, has built. It's called K8.af. It's just Kubernetes failure stories. So if you're an organization that has been doing Kubernetes for over a year, hopefully you've seen this resource. If you're an organization that's looking at getting started with Kubernetes, also make sure to take a look here. It's a collection of a whole bunch of incidents and outages that have happened, as a lot of these organizations have been running Kubernetes from the early versions up to now in like 1.19, and they're starting to see that when they start implementing it with other applications and open source tools that they have in their organizations, they start seeing that there might be more race conditions, they're building more complexity into their network layer. Sometimes they start realizing that the promises that a lot of these tools have provided for them, they're not necessarily as reliable as they once thought. So today we'll actually be taking a little bit of a deep dive of what you can do to get ahead of the curve and learn from Kubernetes failure stories, such as any of the ones in this website. I was trying to pull up some of the latest ones just to kind of like get to talk to you about some of them. There's too many of them to actually get a chance to choose one of them, but the one that I was looking at that was quite interesting was the one that had to do, I'm looking for it right now, totally lost it. When GKE ran out of IP addresses, it was kind of interesting in a sense of when You think that you bought into a platform such as Kubernetes due to it being a lot more reliable, it scales more efficiently for all your needs, and then you also buy into the cloud provider vendor's promise of helping you keep those instances up to date. But sometimes what we don't always think about is how do we validate that we had the right policies in place, that we actually had the resource limits set in place, that our clusters can auto scale to handle that capacity that's needed. So that was very much a nice example of that. I will share a little bit more as we go through it. But just to also get a chance to talk about why failure is really important in everyone's life, but at the same time, when we talk about systems and distributed systems, we really need to come to terms with the fact that we know that our software is going to be breaking, and the world that we're building is relying more and more on the stability of this naturally brittle technology. And we look at this pandemic situation that we're all currently in, and more than ever, we're relying to the internet, to software, to just get by day to day. The challenge that we're facing is that we want to continue innovating and delivering all these amazing things that we're building to our customers, but we also want to minimize that risk of failure as much as possible. So now that we kind of have that in mind, that our systems are going to be failing, the other thing that's really important to keep in mind is that not only is failure harmful for society, your customers, but it's also really, really expensive. And the cost of downtime is not usually something that's on everyone's mind. And if you don't actually know what your organizations or your services cost of downtime is, this is a pretty neat formula that you get to use to kind of ballpark what 1 hour of an outage can cost. And the cost of downtime comes to various different portions of the outage. During the outage, you're losing revenue, your company's not bringing in this money. You also see that the productivity of your employees is going down because now they are firefighting, they're not doing their product work, they're not building out features, they're not looking at bugs, they're not reviewing code reviews. So that is going to cost your organization money. And when we then talk about what happens after the outage, well, you might have some contracts with your customers that if there was an outage that happens and it breaches your service level agreement, your SLA, you actually might need to pay for that customer any chargebacks. So when we're looking at during the outage, after the outage, that's already a lot of money. And depending on what your base, you also might have some regulatory fines that happen because your system was not up and running for the availability that you promised. But the cost of downtime is extremely tricky to quantify. And then we also have some things that are really, really hard to quantify that we consider unquantifiable. And that is the brand deformation, the amount of news, social media, anything that happens that can actually hurt your company's name, your logo, for the fact that they couldn't purchase their favorite shoes, they couldn't buy an airline ticket, they couldn't punch in their PTO or anything like that. And all of that, not only are you losing customers, you're also losing talent. And when we talk about talent, we also then have employee attrition. We know that engineers, site reliability engineers, are highly demanded at current times. And we know that these engineers are sometimes just going to get fed up with constantly firefighting or constantly getting paged at 2, 3 in the morning. Maybe it's not what they signed up for. Maybe there's some SREs that do want that life though. But at the end of the day, we know that all these constant wake ups and not having that balance of work and life is going to lead to pager fatigue, burnout, and eventually lead to your employees leaving your organization. And we also know that word kind of gets around if you're like, oh, that company has a really bad culture in terms of like incidents, so just keep your head up. So you want to make sure to keep those things in mind. And just to give a little bit of an estimate of what an average company loses when they're down, it's around $300,000 for every single hour that they're down. And this is not a high traffic event for organizations or anything like that. I think we also have data around like an estimate of what some e-commerce websites can have. And one of the largest ones, of course, is Amazon. When they're down, they can lose up to $10 million for an hour, and that's not even on a high traffic day. So that brings us to talking about how do we get ahead of this. We're going to get ahead of this by breaking things on purpose. We're about to launch a poll. I'm curious to know and understand what y'all's levels of expertise is in this topic as we go through today's session.
All right, the poll should be up on your screen now. The polling question is, what is your familiarity with chaos engineering? Select from, I run experiments frequently at my org. I've run my first experiment. I've heard about chaos engineering, or this is my first time hearing about chaos engineering. Go ahead and make your selection. And while everybody is making their choice, just a quick reminder that that we are taking questions from the audience at any time during the presentation. So if you do have a question for Anna, like I said, anytime, you don't have to wait for the question and answer period. You can go ahead and use your GoToWebinar control panel and submit your question. And hopefully we will have plenty of time at the end to do question and answer period and get everyone's questions answered. Okay, I am going to go ahead and close out the poll now in 3, 2, 1. Anna, now you can go ahead and get back to your presentation.
Thank you. And like was mentioned, make sure to submit your questions. I'm really happy to dive a little bit more towards the end of Q&A and things that y'all want to hear. I see that most folks have heard about chaos engineering, but maybe have never gotten a chance to learn more about what experiments would help their infrastructure. So I'm excited to have you all here. So to get started, for the folks that have never heard around this space, we are going to give a definition around chaos engineering. Chaos engineering is the science of performing intentional experimentation on a system by injecting precise and measured amounts of harm in order for us to actually observe how the system responds for the purpose of improving the system's resilience. So that's a lot of words. If you take anything from it, remember experimentations and injecting of amounts of harm, but always remember that it's for the purpose of reliability. And if you want a short, simple, and sweet definition, this is Gremlin's definition. Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. This is one of my favorite definitions because it's very much straight to the point on we're doing this in a planned way. We're doing this in a thoughtful way. This is not about breaking production. This is not about making sure that our system, our team actually is going to wake up if they were to get paged at 2 in the morning or anything like that. This is in order for us to actually understand our systems more, for us to be able to make our systems more reliable, and at the end of the day, goes back to making sure that our customers always have a good experience. With that, I would love to introduce myself. My name is Ana Margarita Medina. I'm a senior chaos engineer at Gremlin. I've been at Gremlin for 2 years and around 8 months. Prior to being at Gremlin, I worked at Uber, Google, a credit union in Florida, a startup, and I've gotten a chance to work across the stack. I got started as a front-end developer, switched on to back-end developer, then did mobile applications, and later switched to systems. So it's been really cool to now get a chance to come back into site reliability engineering and specifically focus around chaos engineering and kind of bring to the front how we need to think about reliability as a whole in the software engineering industry. And with that, I also like to mention that I'm a proud Latina. I was born and raised in Costa Rica. My parents are from Nicaragua, and I currently reside in San Francisco. So always love calling out representation since sometimes there's not enough of us out there. For those that had never heard around chaos engineering or understand why chaos engineering is really important in today's systems, specifically around Kubernetes, we want to talk about that complexity. We want to talk about how it's getting more difficult to actually operate our systems, not only because of scale, but just because we have so much more to manage. And we have this pressure from the industry, from our customers, from our upper leadership to constantly innovate, for us to have all the new types of infrastructure, application architectures, and of course, be at the latest development processes. When we look back in time, we look back at our legacy applications, and we used to just run our project management on waterfall. We just had one annual release, and we had just one entire code repo that maintained everything. And that was our monolith architecture, and everything worked. But also everything was just running on-prem. We just had only 100 hundreds of resources to manage. This was all possibly just on physical data centers, private data centers and stuff. We were able to shift left and we re-architected everything, and cloud native and DevOps happen. And now with these technologies and practices, we're able to have daily releases that allows for us to innovate faster and actually get to do some really, really cool work. We also have seen how microservices allow for us to decouple dependencies and just push out small features at a faster rate than ever before. And of course, with the adoption of Kubernetes, we went from just managing hundreds of resources to now hundreds of thousands of resources from just more data centers, cloud providers, clusters, pods, thinking about the resource consumptions that all of our cluster has, and all of that is just getting much more and more complex as we go through our Kubernetes journeys. So how do we actually get started with implementing the experiments that we talk about with chaos engineering that allow for us to understand the complexity of our systems a little bit more, and also make sure that as we make them more complex, we're keeping reliability as one of the first things that we constantly think about. Prior to getting started into how do we actually implement these experiments, I wanted to touch base on some terminology around chaos engineering. I wanted to discuss that you always want to go ahead and follow an experiment. You want to follow the scientific method every single time. There is science to the back of chaos engineering. You want to be thoughtful about it. With that, of course, comes that you always want to have a hypothesis. You want to know what happens when you inject something into your system and what is the expected outcome of it. With that, you also want to be safe when you're performing chaos engineering experiments. So first, we have a term called blast radius. Blast radius is in terms of like, what percent of my fleet am I launching this experiment in? How many pods am I affecting? What is actually the impact that this experiment is going to have? Then we have magnitude. Magnitude is the intensity of the chaos engineering experiment. So when we talk about experiments, you always want to start small. So you want to start off maybe with just one host out of the 100 that you have. And the first experiment, let's say it's going to be CPU. You want to start off by just injecting 10% of CPU, then go up to 20% and such. And another major technology that we need to keep in mind that's really, really important is abort conditions. Abort conditions are those conditions that are going to cause you to halt an experiment. So you always want to make sure that you're thinking about your conditions as you're building your hypothesis, and that could be things as your service level agreements getting too close. This could be something as response rates. This can be as your traffic rate completely dropping. All of these kind of pertain to any KPI that your business is going to have. When it comes to doing chaos engineering experiment, just to give you a little bit of a rundown of what you want to do, is that you always want to make sure to just observe your system. You want to understand what your system looks like on a normal day-to-day basis, or depending on when you're running it, what does the system look like? Then you want to go ahead and just baseline your metrics. This is something you can do by implementing service level objectives and service level indicators. You're able to understand what are the things that matter the most in your systems. Then you can actually go ahead and form the hypothesis with those abort conditions, since you already have those metrics. You have something to go back to in data and correlate the effects of your experiments. Then you want to go ahead and define that blast radius, define that magnitude. Where am I running that experiment? How small is this experiment going to be? Then after you run that experiment, you want to analyze those results. If the experiment is successful, of course, you want to go ahead and expand that experiment and run it once again. And one of the other major things with chaos engineering is that you always want to make sure to share your results. You want to share your results with your upper leadership, with your engineering team, go out to a conference and talk about some of the vulnerabilities that you have found or that you have learned from just building your systems. And you always want to keep in mind that as you go through the experiments, you want to just be scaling that magnitude as you go. You want to start off with a small impact, a small experiment, and then gradually increase as you see it go well. We've been helping a lot of organizations get started in becoming cloud native, start adopting Kubernetes, or just kind of try for them or help them figure out what is the best Kubernetes implementation that they can have. But some other ways that some organizations are using chaos engineering is that they actually are using it to train their engineering teams how to be on call. This could be your interns, your new grads, your senior engineer that's the first time that they're coming on for the system. You're also able to validate monitoring. I know that when I worked at a larger organization as a site reliability engineer, we had many monitoring observability tools that the runbook just didn't always have the most up-to-date links, or the dashboards could be missing the proper tags. So you always want to make sure you validate that monitoring so that your engineering teams have all the resources ready to go when it's needed. And of course, you want to go ahead and constantly keep in mind right-sizing your infrastructure so the cost of operation for your organization stay down. And I think one of the most important parts of chaos engineering too is that you want to go ahead and replicate past failures in order to not drift into them later on, to not regress into things that we know that can happen to your systems. So you want to go look at conditions that have happened that led you to maybe your largest outage, and then replicate it so you can make sure that you're getting ahead of it. And with that, I get to start taking us to our demo. That's what I'll be doing in my next slide. And first, I wanted to give a little bit of an overview of what today's demo environment is going to look like first. We're going to be using the Google Cloud microservice demo application. This is an open source project built together by the Google Cloud team. It's pretty neat application if you're looking at building a demo around Kubernetes. It comes with 10 tiers of microservices. So we have our standard front end where our traffic is being served through. From there, we have various microservices that we're able to see just on that front page. We have our cart service, our recommendation service, ad service, product catalog service. All these things are getting pulled in to these e-commerce website that I'm about to show you in a minute. When we look at the cart service, we see that the cart service has a caching layer based on Redis, and we're able to get to that later on. Our recommendation service is pulling in data from the product catalog service that has all the information about the items that are on the online boutique shop. When we look at our checkout service, of course, this being one of the most critical parts of our application, we see that this has a lot more dependencies. So we have our email service, we have our payment service, shipping service, currency service. All these things come and play together in order for folks to be able to add things to the cart and go through the checkout flow and get the proper messaging. And we also have the other, a little bit more decoupled microservice, that's the ad service, that will also probably get a chance to run an experiment on. To give you just a little bit of an overview of what the environment looks like when it's been deployed, I'm running this on a DigitalOcean Kubernetes cluster. We've already installed Gremlin, we have installed Datadog for our monitoring tool, and we have this up and running on 2 nodes. When we get to it, we get to our front end, I'm able to browse it. I see there's a few items on it. Today, I feel like I want to buy a film camera. It's really expensive, but we're going to go for it and add it. I want to go back and continue browsing. I also want to buy some plants so I can take photos of them. So I'm going to add that to my cart. Go back to my front page. I also just want to change my currency in order to look at what the other prices will be. Because I'm feeling adventurous and it's also the pandemic and I want to pick up a new hobby, I'll buy a city bike too. I see that I have my 5 items in my cart. It has my shipping costs, how much it's going to cost in euros. All my checkout information has already been filled out. I place my order and my order is complete. There was no latency, there was no images that did not load up or anything. Everything was pretty seamless for the user. I mentioned that I have deployed Datadog in the back to kind of keep us as our monitoring for us to observe our system today. To give an overview of that, I wanted to just kind of show what the system metrics look like right now prior to us running any chaos engineer experiments. So we have our 2 nodes that are in our cluster. We see that the CPU for today's environment is just very minimal, or like less than 27%. We have our memory being almost just at 2 gigs. Our system IO has some usage right now, our disk, network bytes. We can come down to the service metrics, and we can look that we have some response times coming in for every single microservice that we talked about earlier. We see that right now everything is almost under 1 millisecond of latency. So you get to have the graph view, and then you have some of the more visual. When we look at our Kubernetes metrics, we see that we do have around 62 running containers in terms of what's running on each node. I can take a deep dive just to see that mostly everything seems to be running okay. We see that our agent of Datadog is consuming a little bit more resources on our load generator too. We see what are the ones that are the most CPU intensive, but so far everything looks pretty normal, nothing too alarming. We also have a Kubernetes dashboard from Datadog that we can look just to see what the actual events are going on. The daemon says the deployments. I'll come back to these as we run our experiments. And we're going to be using Gremlin today in order for us to run our chaos engineer experiments. So we have deployed Gremlin already on our 2-node cluster, and we get a chance to run through some attacks using the attack flow. Gremlin also offers other parts of the platform in order for you to bundle together more attacks or run chaos engineer experiments on serverless environments. To go back to the demo that I have prepared for y'all, the first experiment that we're going to be running is that 101 hello world of chaos engineering. We want to go ahead and just validate our monitoring. The reason I want to do this is that I just want to make sure that I have everything up and running. So I'm just going to run a simple CPU experiment for injecting 60% of CPU into my system. My abort condition is going to be that if my application is not responsive, I'm going to go ahead and stop my experiment. And for the hypothesis is that when I inject this CPU, I expect it to correlate to my Datadog. So we're just going to make a simple attack on here. We'll head on over to attacks. We'll then target all of our hosts, which are our 2 nodes. I just want the impact to happen to half of that. So my blast radius is 50%. When it comes to choosing my Gremlin, I am going to just head on over to the resource layer, then select my CPU experiment. On here, I'm going to make this one just run for 30 seconds. And I want it to consume 60% CPU on each core. So I've changed that to all cores too. And I'm going to go ahead and unleash my Gremlin. We see that right now the attack is pending. We'll be able to have a little bit more information once it starts running, and we'll see that Gremlin will also start reporting on what the CPU looks like for the node that this is actually targeting, since we're only targeting one of the nodes in the 2-node cluster. If I was to hit an abort condition, the button I would want to press is either halt or halt all attacks. I want to go back to my Datadog dashboard just to make sure that my experiment is running. I can start seeing now here that my CPU is starting to increase. We see it start going up to 37% for just one node. And Datadog and Gremlin do have an integration together, so that is the red line that you see. I can head on over and see that I have my attack that has begun. I see right now my node is at 67.87 on CPU usage, which is just right as expected. And that is just a really short, simple experiment in order for us to kind of get a handle on what an experiment in any type of system could be, an easy one that you just get to validate. When the experiment ends, you'll see that things go back to what they were prior to the experiment starting, and you'll also see another red line come up shortly for our experiment to end. I've gotten a chance to work a lot on chaos engineering around Kubernetes, around cloud native, the type of complexities that we see in Kubernetes versus just standalone servers sometimes, or like non-microservice environments are a little bit different. And 2 of the things that I've learned out of all of this is that you always want to make sure to set up auto scaling on your Kubernetes clusters, whether that's vertical or horizontal, or that you're doing this through your cloud provider to make sure you always have enough resources. And you always want to be testing on those resource limits. So today we'll do some of those experiments based on that knowledge. The first one I have for us today is running another experiment to make sure that we can actually handle a resource consumption a lot more properly. So with this one, I forgot to change that the attack is actually going to be a memory attack. So I'm going to go ahead and make sure that it says memory on my next experiment. But on this one, it's going to be a little bit different. Our abort conditions are going to be a little bit more specific because we are going to be injecting a little bit more of an impact in our cluster. We want to make sure that if our application is not responsive when we inject, when we consume memory resources, or we start seeing any HTTP errors around 400s, 500s, or we see our response rates increasing over 5 milliseconds, we want to go ahead and stop that. So with that, we're going to head back over to Gremlin and start a new experiment. When we come to Gremlin, there's various things you can do. Right now, the first attack I just did it over on the host layer. We can start targeting things on the container layer, or we can head on over to our Kubernetes. For this one, I'm going to be doing it on our Kubernetes layer offering. We get to start by selecting the cluster that we want to use today. This is my group 00 cluster that I'll be using. If I wanted to actually scope it down by namespace, I'm able to do that. We don't have too many namespaces on this environment, so we'll just keep it there. I can find any of the resources that I have for my Kubernetes cluster on here. Today's environments, I deployed it, and it's mostly all just deployments, so that's the reason you only get to see deployments out here. We are going to just go over to cart service, and that's in cart service is where we're actually going to consume more of those memory resources. If you wanted to target more than one container, you're more than welcome to, but for the sake of keeping the blast radius always small, we're just going to do one. We'll head on over to choose a gremlin, and we'll select the memory experiment. For this one, we're just going to run it for 60 seconds, and we want it to actually only consume just 0.5 gigabytes. Just going to keep it at the default small magnitude settings. And on this one, we're able to select if we wanted to actually target an exact container for this one, or we wanted to target any container that actually matches this deployment, or if you wanted to target all containers. So if you're wanting to be really, really specific around your pods and learning more about those, this is another great feature that Gremlin just recently launched. So we're going to keep it at all containers for this one. There's only one container that's running this cart service, so not much to see on that portion of it for this demo. We see that we have it as pending. We're just going to wait for it to start showing up as running, and then I'll head back to our demo environment just to see if things are running smooth. It's now running. So in the next 60 seconds, we'll see that our system's going to be experimenting a little bit of a chaos engineer experiment. In my hypothesis, this application would be running without much issues since it's just a small memory spike, but we start seeing that it just kind of starts being really, really slow. We don't see any responsiveness. When we head back into our metrics over in Datadog, the one that I mentioned that I was going to care about too was response times. If it was to go over 500, and so far things seem to be going okay. At least on the monitoring side, everything looks like it's running smooth, but as the user goes, we actually see that our application is not responsive. So we're going to halt that experiment. And this is the reason that I always make sure to touch upon abort conditions. When you run any chaos engineer experiment, you want to start looking at what actually happens when those experiments start consuming resources and what does the customer see. So we're going to load it back up. I'll just give it a little bit of time to come back online. And we hit our first 500 error. And when we see this error page, some people think that this is the worst thing ever. Well, no, we hit an error page, and this actually gets to show us that there's actually something else that we have not being handled properly in our applications. So we just saw that from this experiment, our cluster is not set up to just get a little bit more of consumption in the memory layer. That's something that we can build in to make sure that every single node just has more memory available, or we actually cap our cart service to have a little bit less consumption already so that it's actually able to handle that 0.5 gigabyte increase. And this second win that we get to have is that this 500 internal server error first should not be shown to a user as this. Maybe you would want to actually have it on a better error page that the customer is actually able to understand. But there's also something to be said around a customer being able to see an entire stack trace of this transition failure that happened when it wasn't able to connect. When we see something like this, we already think that this is already not a good UI UX experience for any user. But if you're a financial institution, if you're processing any payments or you have any login information, imagine if the stack trace actually had any of that information on here, and now your users actually explicitly seeing. You want to make sure to keep little things like that as in top of mind when you're building any type of application or software. So this is something that you definitely would want to put in as a Jira ticket to make sure that your team knows, hey, we just saw that when our resource in Kubernetes actually suffered a failure as it wasn't able to consume more resources, we see that we have this HTTP 500 error page that's not properly done for the user. So let's go ahead and change that. So we saw that by making sure that you're just doing little things on your Kubernetes cluster, you can also have some other side wins and make sure that if something was to not be reliable in your Kubernetes cluster, your user, your customer actually does not get a chance to be affected by it. So with this one, my hypothesis was completely wrong. When I consumed those memory resources, my application did not handle it, and it definitely did not auto scale to handle it. So this is that one thing that I was mentioning earlier. Last year, I got a chance to speak at KubeCon, so my team and I did a lot of research around what were the most common Kubernetes failures that were happening a year ago. So a year ago, 50% of the outages that we were seeing was actually all could have been prevented if folks had set up auto scaling in many different aspects of it. So you want to make sure to keep that as if you only take one thing of today's webinar, you want to make sure to always set up auto scaling on your cluster and that you're validating that in various ways. Next up, we have another chaos engineering experiment. This one is around improving another one around improving the user experience. We want to make sure that when our application can't access a resource, the user is actually not able to notice that it's not working. So we're going to do a different type of experiment. The experiments I've done recently have been on the state layer. We're going to, the resource layer. We're going to move on to the network layer. On the network layer, it's actually my favorite type of chaos engineering to do. With this one, we're going to be doing a latency experiment. What doing a latency experiment entails is that we're going to be injecting just milliseconds of latency to either an API call, to a container. For this one, we're going to just be running it on one container, one deployment, and it was going to be the cart service. So when I see that my cart service has 400 milliseconds of latency, our Redis cart is actually our cart service is actually just put together on the Redis cart. So what I'm going to be targeting specifically is that caching layer. If my caching layer has a latency increase, it should not really have an issue because our application should still be working properly within real time. So let's go ahead and actually test that hypothesis. We'll head back over to Gremlin. We'll select a new attack. This one, we're going to be doing it through containers instead of host or Kubernetes. You would be able to get similar effects if you were to go through either one. You just have to be a little bit more specific on each implementation. Gremlin is able to pick up the names of the deployments, the tags, and grab some of those tags also from your cloud providers. So I mentioned that what we're going to be targeting on this one is our Redis cart. So I can just go ahead and select my Redis cart application. We see that this is just one container within my 2 nodes. I wanted to target 100% of what that one container is. Then we'll head on over to choose a gremlin. As I mentioned, we'll then do the network layer. Under the network layer, we have various experiment that makes attacks that you can run. We're going to be adding a latency experiment. We're going to keep the length just at 60 seconds, but if you wanted to observe it longer, you can always make it lengthier. We are going to inject 400 milliseconds of latency. We're going to keep everything else just as default. We're going to go ahead and unleash static gremlin. We see that everything is just pending. I'm just going to wait for it to start running. Perfect. We'll head back over to our online boutique. We just kind of want to see what the 400 milliseconds of latency do to our Redis cart. Everything in terms of just browsing around seems to be going okay. Add my vintage typewriter, check out, place the order. Awesome. By adding just so far, at least adding the 400 milliseconds of latency, it's acting really, really smooth. It's almost as if an experiment is not running, which is pretty nice to see the cluster be resilient to that. Just to validate, we were trying to just look at what the Redis cart has on here. We're still not seeing any spikes. So the experiment is running smoothly. I mentioned that we did have some Redis metrics here at the back. We see that there was a latency spike when we ran the earlier experiment. For this one, we are seeing that spike, but it's very, very little compared to the spike that we saw earlier. So things are working smooth. We're going to go back and just try one more time. I added something to my cart. Everything worked well. We'll go back. We'll add the home barista kit. Sweet. This is working as expected. As I mentioned earlier, when my caching layer has a latency increase, my application should work without any issues. That hypothesis is correct. So now that we saw this, one of the other things that you can do is that you can also think about what do you do after you run a latency experiment. You want to think about other things that can happen if anything happens to that service. So part of graceful degradation is making sure that our customers always have a good experience. So let me just validate that. My latency experiment ended. One of the things that we can do now that we saw that if there was a latency increase that happened within our Redis cart and everything worked properly, now we could ask ourselves what happened if our entire Redis cart just stopped serving traffic. So one of the other network attacks that Gremlin has is the black hole attack. It drops all matching traffic. So for this, it will drop all of the traffic being served into the Redis cart. So if our Redis cart was to have issues that it just completely stops working, what would happen? Very similar to the last hypothesis, I think that if our caching layer goes missing, our application should work as properly. Our abort conditions are going to be that our application is not responsive. If we see an increase in errors, we're going to stop that. And if we see response rates increasing a little too much, we'll stop it as well. So we're now running that black hole experiment on the Redis cart. We saw that our application handled the 400 milliseconds of latency okay. So now we want to know what happens if our Redis cart just completely stops serving traffic. Because as a caching layer, the hypothesis is going to be that everything runs smooth. Uh-oh, well, that is another 500 error. And we see just another one that we have an entire stack trace on. We see that we can't access the cart storage. We see that the Redis has a timeout exception. We'll try loading it up again just in case it was only like a race condition. Nope, we're also stopping this experiment. When we look back at the architecture diagram that we have here for this demo environment, we see that the Redis layer is part of the cart service, but it's just a caching layer. So our hypothesis was okay to assume that if our caching layer went missing, our application would still be reliable. And we realized that it wasn't. And this is something that happens very much in distributed systems, complex system, Kubernetes architecture diagrams, where little things like this kind of get overlooked. So that's another easy experiment that you can have in order to really improve the reliability of your cluster. Look at what some of those interdependencies that you really don't think that are critical, go ahead and validate that they're not critical. Make sure that you're staying on top of that. We see that I've just halted my black hole attack. I just kind of want to go back and make sure that everything's running smooth. Our application should be coming back up in just 1 second. But with that, I do want to take a moment to head back to slides to get a chance to close us out before Q&A. So as I went through today, you saw that we were able to start injecting a little bit of failures within our systems for us to be able to see what would happen. At the end of the day, with chaos engineering, the main purpose of it is going to be that we want to reduce the cost of downtime. We want to reduce the amount of incidents. But at the end of the day, it comes back to making sure that your engineers are constantly just focusing on what their roles are, whether it's building, operating, or supporting other teams to help them build more resilient systems. We want them to focus on that and spend less time firefighting and worrying about any possible outages that can happen. I do work at Gremlin, and I wanted to give a little bit of an overview at what the Gremlin platform looks like. We have various engineers that are coming with so much different expertise in building complex systems and other chaos engineering platforms at other big corporations. We have a simple and easy to use UI, and the UI also has the same parity as our API. We have SOC 2 auditing that allows for us to be a safe platform to safely run any experiment, and you have that ability to safely also roll back an experiment. You want to make sure that any chaos engineering platform you use allows for you to stop any experiment at any given time. As I mentioned, we have SOC 2 certified. We also have RBAC, MFA, SSO available to make sure that your implementation of a SaaS platform like this goes well. And we have a comprehensive chaos engineering platform that allows for you to look at what happens when you inject chaos engineering into your state layer. You shut down some nodes, some pods. We go down and we exhaust some of the resources of disk, CPU, IO within a Kubernetes cluster. And then on our network layer, like we saw, we want to go ahead and inject that latency, drop all matching traffic. Maybe you want to inject some packet logs. Maybe you want to play around with some of the DNS that happens within Kubernetes. And as a reminder, you are building complex distributed systems, and there are things that you must test for. And if you don't test for them, you might be suffering an outage, and you want to keep that in mind. And at the end of the day, failure happens, is part of life, is part of our systems. But what we do with that learning is what you want to also always reflect on. You want to make sure that you're learning from your past failures. And with that, it comes that you want to run chaos engineering experiments on your entire stack. You want to run this on your monitoring tools, on your CI/CD environments, maybe even on your people systems as well. If you're interested in learning a little bit more about Gremlin too, and you're going to be at KubeCon North America, feel free to stop by the Gremlin booth. We have some other cool stuff going on there. I would also like to invite you to the larger chaos engineering community. We have a community over 5,000 folks across the globe. We come together in meetups and conferences and workshops and stuff like that. And if you want to get started, the fastest way to find us is in Slack. So by going over to gremlin.com/Slack, you can just join us. And part of the community also has these really cool stickers that I really love. If you're interested at getting some of the stickers, head on over to gremlin.com/talks/devops-k8, and you'll be able to just give us your information and we'll ship you some of these awesome stickers. My favorite one is always the pager one, and is the other one? The terminal with the spade. That's the one I kind of want to get printed or tattooed at some point. But with that, I would like to thank you all very much for your time today. I hope you all learned something. I hope you all know how to make your Kubernetes clusters a little bit more reliable. If you're interested in giving Gremlin free a try, head on over to go.gremlin.com/Anna, and you'll be able to sign up for a free account. With that, I'll now open it up for any questions.
Yeah, we've gotten some questions in, but there's time. I think we have about 6 minutes or so for questions. So if you do have a question for Anna, go ahead and use your GoToWebinar control panel. Here's the first one for you. What are the best ways to handle config map configuration misconfigurations errors?
So with those, a lot of it is going to be just a lot of debugging. I know that last time I was playing around with config maps, we were doing it for our dashboard implementations. So we had to go back and forth and really just kind of get it in a template. And then in terms of actually handling the misconfigurations error, a lot of it will come back into how your deployment is being set up within the initial, but I think more on that I would not be able to proficiently give an explanation on.
All right, great. So next question here. This is a good one. How can I convince my manager to let me try this in our production cluster?
We hear that question a lot. We hear that folks are like, I'm scared of telling my manager that I want to start pulling the plug on my Kubernetes cluster, that I want to break my cluster, my pod, whatever that entails. So we tell folks to always kind of start small. You want to go ahead and think about your environments the same way that we look at blast radius. Go ahead and start by doing chaos engineering experiments in your development, your testing, your QA, and then show that to your manager. Like, let them realize that by you testing, playing around just in your pre-prod environments, you actually might get some wins in reliability, and then you can also build those reliability things into your production. So start small and then roll into production. That's going to make it a little bit easier as a manager to understand. And if you're curious about how to talk to your manager around chaos engineering, Gremlin does have a lot of resources around that too.
Awesome. All right, next question. Is there an agent that needs to be installed to run Gremlin and inject test cases on containers?
Yes, so Gremlin has an agent that gets rolled out. We install as just a daemon agent that sits on your host. When it comes to actually deploying in Kubernetes environments, you're able to just do the daemon set. You're also able to use Helm. The way that Gremlin ends up operating is that we spin up a sidecar container, and the sidecar container is the one that's injecting the chaos and running all those experiments. We do have 10 experiments available to run on your containerized environments.
All right, great. So we have time for maybe 2 or 3 more questions here. Let's see. Anna, can you point me to more documentation or videos where I can learn more about Gremlin?
Yeah, head on over to gremlin.com/community. We have a lot of resources there around tutorials, whether it's setting up a Kubernetes cluster and running chaos engineering on it. I built some of those tutorials, whether it's actually learning around what are some of the other things that Gremlin can do? A few months ago, we launched something called status checks. Status checks is just making sure, status checks, it's a health check on your system prior to unleashing a chaos engineer experiment. So part of those conversations around Fortune 500 companies automating chaos engineering experiments was that they wanted to make sure that if chaos was going on into their system, they weren't unleashing more onto it. So we built an automation thing that you can pull into another API and make sure that there's no incidents open, that your response rate is not too high prior to you starting more chaos.
Excellent. Okay, let's see, next question. Is it possible to extend on the functionalities if for any reason I want to build something very specific, not available in the default?
So with Gremlin, you don't have an ability to add another attack per se, but you can definitely talk to our our solutions engineers to how do you like to replicate a certain condition that you're trying to achieve in your Kubernetes cluster. You might think that you want to do it by, like, for example, black holing all traffic, but maybe by injecting packet loss, you'd be able to replicate that same condition that you're trying to suffer. And if you have any other ideas for other chaos engineer experiment attacks, over in the Gremlin application, there's also a product roadmap, and you get to submit any feedback on the product and any ideas of other experiments. We always want to hear about them.
All right, great. I think we have time for one more question, then I'll close it out. Is there a library of chaos engineering attacks I can use for Kubernetes?
Ooh, that's a really good question. Yes. So at Gremlin, we have built scenarios. Scenarios are like various attacks that you can run that are chained together. We have recommended scenarios, and when we come to recommended scenarios, we are also able to narrow down by just containerized containers, and we see that we have a whole bunch of Kubernetes. So over here, it could be a DNS attack that allows for you to make sure that you can handle a DNS outage. It can be something as simple as black holing a region, shutting down a service. So there is a large library to get started with Gremlin and Kubernetes.
Excellent, excellent. Okay, so 3 minutes to the top of the hour. So unfortunately, that's all the time we do have for the question and answer period. But I do want to thank everybody who did submit questions. There's some really good ones there. And if we didn't get to your question, I'm almost positive we got to all of them. But if we didn't get to your question, please know that the folks at Gremlin are getting a copy of all the questions. So they'll be more than happy to follow up with you offline to get your question answered. Also, quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, see that awesome demo, you will have the opportunity to do so. We will be sending out an email that contains a link to access that webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did mention at the top of the hour we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's do that. First winner today is Gary S. Congratulations, Gary. Second winner today is Helena T. Congratulations, Helena. Third winner today is Sean, S-E-A-N-S. And the final winner today, congratulations, Sean. Final winner today is Tony V. Congratulations, Tony. We'll be following up with all 4 of you via email to get your gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. All right, Anna, what a great presentation. Thanks so much for your time and your expertise, and thanks for the demo. Love the demos.
And thank you all. Feel free to reach out via social media or email if you have any other questions. I'm always happy to stay in contact.
All right, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.